Number 30 says a bacteria population is currently exactly 1 million and increasing at a linear rate of 15 per second. What will the population be in 2 weeks? All right, so we have a rate which is 15 bacteria per every second, 1 second. And we want to know what about in 2 weeks. So I want to convert this to number of bacteria per week. So I'm going to just use sort of dimensional analysis ideas or conversion factors. So if those are words that you don't know, conversion factors, or this is the process of dimensional analysis. Those are general terms you can like Google and look up, but the point is to multiply appropriately by certain conversion factors until you get to what you're looking for. So I'm ultimately looking to convert seconds into weeks, but I'm going to leave the bacteria alone. So I don't know how many seconds there are in a week off the top of my head, but I know that I can get closer to a week by going from seconds to minutes. So I know that there are 60 seconds in 1 minute. And I strategically write my conversion factor so that the seconds will cancel. So I think about my units canceling. So obviously it's also true that 1 minute is over 60 seconds. That's still a conversion factor, but it wouldn't help me because it wouldn't help cancel out the seconds. So I put it in the appropriate place, and all of my conversion factors, here's my first one, this has to be equivalent to multiplying by 1. Right? 60 seconds is equal to 1 minute, so I haven't changed the value of this expression because I've just multiplied by 1, a fancy form of 1, something that's convenient to help me convert the bacteria from bacteria per seconds to bacteria per minute. Okay, so those seconds are now gone, but that doesn't help me. Well, it helps me, but it doesn't get me the answer. I want bacteria per week, so now I got to get a little bit closer. So I know that there's 60 minutes in 1 hour. So again, I'm going to strategically do it so that my minutes cancel. And again, I'm still multiplying by something that's equal to 1. So this is another conversion factor. Now I'm in bacteria per hour. Now let's go for days. So 24 hours in 1 day. So now my hours are canceled out. And I have another conversion factor. And finally, we have 7 days in a week. Okay, and so this process can be done to convert really anything to anything else. So now we just multiply across 15 times 60 times 60 times 24 times 7, and we would get 9,072,000. Oh, come on, Word. Sorry, hold on. Okay, 0, 0, 0. Bacteria per, and look across the bottom, 1 times 1 times 1 times 1 times 1. In this case, that's not always true, by the way, when you're doing dimensional analysis. Certainly there can be a denominator. So this is how many we get in 1 week. So we could just double it to find out how much in 2 weeks. So if you double this number, you get part C, 18,144,000. Let's see, why did I write plus 1 million on there? Okay, I got to pause the video for a second. Sorry, let's pause. Oh, good. Good thing I paused it. This is not right. Okay, so it's not choice C. It's not choice C. I fooled myself, I guess, the first time around. We're doubling it. Doubling it does give you the 18 million number. Okay, but the question asks us, what will the population be? So not how much has it doubled, not how much has it increased by, but we start with our original amount, right? We started with 1 million. Okay, and then this is telling us how fast it was increasing, right? It was increasing at a rate of 15 bacteria per second, which is equivalent to this 18 million number in 2 weeks. So we had, this is the amount that it increased, plus we have the million to start with. And that gives us how much we have at the end. So if the question had asked, how much did it increase by in those 2 weeks, then the choice would be C. The question asked, how much is the actual population? It's got to be choice D.